I think that there is reason to think that the primitive clotting system, like the one found in the crab, exists in people, and in this unfortunate situation has been activated.
Dr. Albert Smith explains to a fellow doctor what he thinks might be the reason that one of his patients is suffering from the potentially life-threatening condition of abnormal blood clotting. Dr. Smith believes that we all carry the ancient DNA for the same primitive blood clotting system that's found in crustaceans. And apparently it's being expressed in his patient. Powerful anticoagulant drugs seem to have no effect on reducing these types of blood clots, which increase the risk of a deadly heart attack or stroke.
Would you exhale for me and hold your breath?
And Dr. Smith should know, because not only is he a practicing medical doctor,
this is a fairly advanced and obviously highly specialized fish.
He also has a doctorate in marine biology. For more than 35 years, Dr. Smith has been educating his medical colleagues about the many insights into human diseases that can be gained by studying marine animals. We know that organ systems in humans and fishes are similar on many levels. Vision, internal fertilization, placental nourishment, live birthing, learning, and memory all can be observed in fishes. And from cancerous tumors to heart disease, from scoliosis to kidney disease, fishes must contend with surprisingly many of the maladies that confront humans. But fishes also provide some intriguing solutions. For example, too much urea in our blood is usually a sign of advanced kidney disease. Amazingly, sharks contain in their tissues up to 25 times as much urea as we do.
Something is protecting the shark, especially the enzymes. Urea is very denaturing and very destructive to proteins, such as enzymes.
If we absorb too much iron, it usually indicates a genetic disease called hemochromatosis. If the iron isn't excreted, toxic levels can accumulate in the tissues of the heart, liver, pancreas, and other major organs, leading to a number of health problems.
Now, the tunicate has a substance in its body which pulls and holds onto iron from the seawater, and it's very powerful. There's not a lot of iron in the seawater, but the tunicate substance will pull out what's there and concentrate it thousands of times. If we had that substance, could we use it for hemochromatosis patients to pull the iron, out of their tissues?
The neurotransmitter serotonin has been implicated in aggressive behavior in lobsters, and it appears to play a role in aggression in humans as well. But it's been difficult to gain an understanding of what happens in us because of the many millions of neurons involved. In lobsters, serotonin is concentrated in 120 extraordinarily large neurons, making it far easier to work with. The large muscle cells of comb jellies, or ctenophores, suggest a model for the pathologically giant muscle cells found in the early stages of the most severe form of muscular dystrophy. And sponges provide an opportunity to examine the more primitive aspects of inflammation because they lack the circulatory system reaction that triggers the inflammatory response in vertebrates like ourselves. A compound in the connective tissue in sea cucumbers may help women in labor to increase the stretchability of tissues in their birth canal and thus avoid the surgical process of an episiotomy. Dr. Smith began writing about the medical aspects of marine animals in 1969. Today he focuses on the many exciting discoveries coming out of the Human Genome Project.
At the cellular and molecular levels, we see very, very little difference between us and the lower animals.
Back in 1884, one of the first observations of the immune response was made using the transparent larva of a sea star. Today, at the beginning of the 21st century, we understand that because marine animals have been around for hundreds of millions of years, they've had plenty of time to develop some pretty effective mechanisms for protecting themselves. And now is the time to really learn what they have to show us. For Fast Focus, I'm Dr. Charles Messing.